In this video, we're going to focus on graphing logarithmic functions with transformations, and we're also going to talk about how to write the domain and the range. So let's begin. Let's start with this example. Y is equal to log base 2 of x. Now there's a process that if you use it, it's going to make graphing logarithmic functions very easy. Now the first thing you want to do, whatever's on the inside, you want to set it equal to three things. You want to set it equal to 0, to 1, and to whatever the base is. In this case, the base is 2. And you want to make a table. When you set it equal to 0 and you solve for x, this is going to be the equation of the vertical asymptote. When you set it equal to 1 and 2, whatever values of x that you get are going to be the points that you want to plug in. So let's find y when x is 1. Log 1 is always equal to 0, regardless of the base, because anything raised to the 0 power is 1. Now if we plug in 2, a log base 2 of 2, these are the same, they cancel, it's just 1. 2 to the first power is 1. So now we can graph it. The vertical asymptote is x equals 0, which is basically the y-axis. Now we have the point 1, 0, which is an x-intercept, and 2, 1. So to graph it, start from the vertical asymptote and follow the 2 points. And that's a simple way to graph logarithmic functions. Now let's talk about how to write the domain and range. The domain represents all of the allowed x values that the function can have. So analyze the graph from left to right. The lowest x value is 0, the highest is infinity, because the graph will keep going towards the right. So the domain starts from the vertical asymptote and it goes all the way to the right to infinity. Now for the range. For the logarithmic functions, the range is always going to be all real numbers, negative infinity to infinity. If you look at the graph, the lowest y value is negative infinity and the highest is infinity. As this curve moves to the right, it's going to keep going up, all the way to positive infinity. So the range is always the same for a logarithmic function. The domain will have the vertical asymptote included in it. Now let's talk about the transformations of this graph. So as you can see, log x basically has a vertical asymptote of x equals 0, and it goes towards the right. That is, it moves towards quadrant 1. Now what if we have negative log x? What's going to happen? How will the graph change? If you put a negative in front, it's going to reflect over the x-axis. So it's going to look like this. Now what happens if we put a negative in front of the x instead of in front of the log? In this case, it's going to reflect over the y-axis. So relative to this graph, it's going to go towards the left. And what if we have a negative in front of the log and in front of x? In this case, it's going to reflect over the origin, so it's going to go towards quadrant 3. Now, if you have difficulty remembering this, here's something that can help you. Let's say that the sign in front of x is associated with x, and the sign in front of log is associated with y. When x and y are both positive, the graph is going to go towards quadrant 1. Positive x is towards the right. Positive y is the upward side of the graph. So it's going to go towards quadrant 1, where x and y are positive. In the second example, x is positive, but y is negative. X is positive towards the right, y is negative as you go down. So it's going to go towards quadrant 4. Now for the third example, x is negative, but y is positive. So x is negative on the left side as you go towards the left, and y is positive as you go up across the graph. So this is towards quadrant 2. By the way, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, for the last one, x is negative as you go towards the left, y is negative when you go down. So when x and y are both negative, it's going to go towards quadrant 3. This is useful for the transformation of any function. So if you understand that, you can easily tell where the graph is going to go if you wish to graph using transformations. Now, starting from this function, how can we graph the following functions? And let's just draw a rough sketch. So if log x is basically that function, what is log x minus 2? The vertical asymptote is going to shift 2 units to the right. If you set x minus 2 equal to 0, x will be 2. So the graph is going to look something like this. It shifts 2 units to the right. And let's say if we have log x plus 3, it's going to shift 3 units to the left, but it's still going towards quadrant 1. So it looks like that. Now what about this one? Let's say if we have negative log x plus 2. Let's draw a rough sketch of this graph. So the vertical asymptote shifts 2 units to the left. And if we had positive log x plus 2, it would look like this. But putting a negative in front of it, it's going to reflect over the x-axis. So we have a positive x value, a negative y value. So it's going to go towards quadrant 4. Here x is positive towards the right, y is negative as you go down. So the graph is going to go this way. So if you want to write the domain for this function, it's going to start from the vertical asymptote of 2 and go to infinity. So it's 2 to infinity. The range is going to be all real numbers, negative infinity to infinity. Let's try one more example using transformations. So let's say if we have log 3 minus x. So to find the vertical asymptote, set the inside equal to 0. So x is 3. Therefore, the vertical asymptote shifts 3 units to the right. But notice that x is negative, y is positive. X is negative towards the left side. Y is positive as you go up. So therefore, this graph is going to go towards quadrant 2. So it's going to start from the asymptote and go towards quadrant 2, where x is negative and where y is positive. So as you can see, it reflects over the vertical asymptote when you have a negative in front of x. So what about the domain? The lowest x value is negative infinity, the highest is 3. So the domain is going to be negative infinity to negative 3. To positive 3. If you plug in 4 or any number beyond 3, you're going to get a negative number. Log negative 1 does not exist. If you type it in your calculator, you're going to get a math error. So now that we spent considerable time talking about how to graph logarithmic functions using transformations, now let's focus on how to draw an accurate sketch by plotting points. Because using transformations, you can just get a rough sketch, which is good enough, but sometimes you may need a perfect sketch or an accurate sketch. So let's try this example. Let's say that y is equal to log base 3 x plus 2 minus 1. So the first thing you should do is set the inside part of the log, that is the x plus 2 part, equal to 3 things. 0 to get the vertical asymptote, 1, and also whatever the base is. In this case, the base is 3. So the vertical asymptote is x is equal to negative 2. And the 2 points that we're going to use, if we solve for x in that equation, 1 minus 2 is negative 1. Here 3 minus 2 is 1. So we're going to use these 2 points. Now let's find a y value that corresponds to these x values. So if we plug in -1 into the equation, -1 plus 2 is 1. Log 1 is always 0. 0 minus 1 is -1. Now let's plug in +1. 1 plus 2 is 3. Log base 3 of 3 is 1. 1 minus 1 is 0. So all you need really to draw a nice sketch is you need the vertical asymptote and 2 points. If you have that, it's always going to work out. So now let's plot the vertical asymptote, which is at -2. And let's plot the 2 points. The first one is -1, -1, and the second point is 1, 0, which is an x-intercept. So always start the graph from the vertical asymptote and follow the 2 points. So the graph is going to look like this. As you follow the 2 points, you will always travel, or you can always go towards the right direction. So you don't have to worry about if x is positive or if y is negative. Using this method, it's just going to work out. So now let's write the domain. The lowest x value is the vertical asymptote, which is -2, and the highest is +infinity. So the domain is -2 to infinity, and the range, as always, is all real numbers. So now it's your turn. Feel free to pause the video and plot this function. Also, write the domain and range as well. So take a minute and go ahead and work on it. So let's set the inside part equal to 3 things: 0, 1, and whatever the base is. In this case, the base is 4. So the vertical asymptote is x is equal to 3, and the 2 points that we need to plug in. From this equation, if we solve for x is going to be 1 plus 3, which is 4. And using this equation, it's going to be 4 plus 3, which is 7. So now let's calculate the y values. Let's use that equation. So if we plug in 4, 4 minus 3 is 1. Log 1 is always 0. 0 plus 2 is 2. Now let's plug in 7. Log base 4, 7 minus 3 plus 2. 7 minus 3 is 4. Log base 4, 4, because they're the same, will be 1. 4 to the first power is 1. And 1 plus 2 is 3. So now we can graph it. By the way, if you want a better understanding of simplifying logs, feel free to check out my channel and look for my algebra playlist. I have a few videos on logarithms. I think one of them is entitled Logarithms Review. So check that out, and it's going to give you a good overview of not only graphing logarithmic functions, but simplifying them, condensing them, solving logarithmic equations, the whole 9 yards. So feel free to check that out. So let's begin by plotting the vertical asymptote, which is at, well, first I need a better graph, because the majority of the graph is on the right side. The vertical asymptote is x is equal to 3. Now let's plot the points. So we have the point 4, 2, which is here, and 7, 3. So start from the vertical asymptote and just follow the 2 points. And that's the graph. The domain is going to be from 4 to infinity. And so that's it for this function. So now what about